Okay, so I'm going to be giving you a lecture, quote unquote, on the exercise physiology lab that we did. And on my screen, you can see that this is the questions for the activity. So, question one was part A. It's as exercise begins, the rate and depth of respirations increases. And what is the physiological difference between exercise hyper hypernia and pathological hyperventilation as might occur in a panic attack? So I said that the exercise hypernia is an increase in breathing rate when more oxygen is needed and releasing more CO2 during exercise. And the pathological hyperventilation, it's not a normal breathing response that causes an increase in respiration rate, which leads to alkalosis. And part B is cardiac output, which also increases significantly during exercise. What are the two ways the heart can increase cardiac output? And the answer is either an increase in heart rate or an increase in stroke volume. Question two is look at the baseline data in the table and fill out the rest of it with your predicted changes. So here are the baseline numbers for heart rate, tidal volume, respiratory rate, hemoglobin saturation, carbon dioxide clearance, oxygen consumption, body temperature, and the mean arterial pressure. So the changes during exercise is an increase in all other than hemoglobin saturation. And for recovery, it's a decrease in all other than hemoglobin saturation. And that is because the hemoglobin would be less saturated because it's being used uh, more often during exercise. So it won't be as saturated because it's cycling through and having more oxygen being put in and taken out versus a consistent, steady oxygenation of the hemoglobin. Question three. What happens to heart rate, blood pressure, hemoglobin saturation, carbon dioxide clearance, oxygen consumption, and body temperature during an acute bout of exercise, during recovery, and why do these changes occur? So, heart rate, tidal volume, and respiratory rate all increase to provide more oxygen to the body and to exhale more carbon dioxide as a byproduct. The hemoglobin saturation decreases slightly because it unloads more oxygen, as in it gets rid of more oxygen from the body because your muscles need it. The CO2 clearance and O2 consumption increase because of an increase in tissue metabolism. So your body is using more of the oxygen, so it's increasing the consumption, which means the byproduct is also having an increase of, there's going to be an increase of the byproduct, which is CO2. Your body temperature increases because of all the friction of the skeletal muscles. It creates heat, so your body will end up having it'll be a lot hotter. And the mean arterial pressure increases slightly as the blood pressure goes up, because as you work out, your blood pressure goes up because more blood needs to be provided to the body. And here I have all the different uh, groups, I guess you could say. It's heart rate, blood pressure. Well, that's spelled wrong. Hemoglobin saturation, carbon dioxide clearance, oxygen consumption, and body temperature. And I have E for an exercise, which is kind of what happened in the first um, little thing I showed you, the table. Sorry, I don't know what's going on. All right. And here's the during rest. All right. Question number 4. Compared to a pH of 7.4, hemoglobin at a pH of 7.5 binds more or less binds oxygen more or less strongly, causing it to create release more or less oxygen in tissues? And the answer is it binds more oxygen and releases less oxygen into the tissues. Compared to a pH of 7.4, hemoglobin binds more. Okay, that's what I said. Right. Sorry. Question number 5 is asking about the control in the experiment. And the control in this experiment is the baselines of all the participants, because you can't have, we did it all in one day, so the participant can't have a baseline run of a day before or something. So they had to use their baseline of each, like the just the resting rate of the each participant that day. And question number 6 is, excuse me, uh, it states that an exercising subject has the following measurements. Here they are. I don't feel like reading them. And it asks you to calculate oxygen consumption and carbon dioxide clearance and to show your work. And here I have, for the oxygen consumption, I have the 0.29 times 0.109 times 2 liters times 20 breaths per minute equals 4 liters a minute of the O2 consumption. And the clearance, I did 0.05 times 2 liters times 20 breaths, which equaled 2 liters per minute. All right, and here I have a picture, and this is helping me explain the way um, the saturation of your blood versus how the blood goes through your body. And I mean, these are all labeled as to what this is, but I just use this picture as a great way to describe exactly where the blood flows. So if you have an increase in blood pressure and heart rate, it's the blood is going to move quicker throughout the body. So it's going to go from being deoxygenated into the heart in through the lungs to get oxygenated back to the heart, back through the body to become deoxygenated when the body needs it. That's going to happen a lot faster. So with an increase in heart rate, there's going to be an increase in respiration rate. So you're getting more oxygenated blood, which is also going to lead to uh, the hemoglobin becoming saturated, but it's not going to be as saturated as it would be on a normal working heart basis. So yeah, this picture just helps me explain how the blood flows from the heart through the body, back from the body to the heart to then become saturated with oxygen again. And this just occurs more and more rapidly during exercise. And yeah, that's all I have. Thank you. And that was my presentation on exercise physiology.